Water flows. No matter what amount, it always obeys the same laws. It evades obstacles, evens out differences, stops and rises if its flow is blocked. Electric energy reacts just the same. Today we will explain to you the principles of electricity with the help of water. So let's take away a little amount of water. For our experimental setup, we connected two vessels to each other, attaching a shutoff valve on one end of the connection. The filled vessel represents the positive pole. It has an excess charge. This tries to even out in the direction of the empty vessel, the negative pole. The difference of charge between the full and the empty vessel is called voltage. The bigger the difference of charges in both vessels, the higher the voltage. With the voltage V, we now have got the first parameter of one of the most important laws in electricity, Ohm's law. The electric voltage is measured in the unit volt, V. If we now open up the shutoff valve, the water will flow from one vessel into the other. The difference of charge will be evened out from the positive to the negative pole. This balancing out of flowing water is called current. It is the directed motion of charges from the positive to the negative pole. The amount of flowing water can be compared to the intensity of current, I, in electricity. It is measured in amperes, A, and represents the amount of charges conducted in a defined time. I is the second parameter of Ohm's law. Since Ohm's law is determined by three parameters, we need a further one to complete it. This is the resistance. In this case, the water tap represents the resistance. If the water tap is closed, the resistance is very large and the water pressure in front of the tap is high. In electricity, this means we have maximum voltage. If we open the tap, the resistance becomes less. Water flows through the tap and voltage decreases. If we close the tap again, the resistance increases, the flow is stopped, and the pressure in front of the tap increases too. The electric resistance R is measured in units of ohms. But how does electricity work in the car? Let's start with the car battery. Please note that there is no conduction yet. Voltage is applied, it exists, but is not used at the moment. The light switch in the gulf is the resistance. At the moment, it is not turned on. The conduction is interrupted by the switch. The resistance is so large that no current is able to flow. As soon as we turn on the switch, its resistance is very small, and a current can flow from the battery to the headlamp and back to the battery again. A charge compensation takes place. Ohm's law states that voltage, current, and resistance are always connected with each other. If current flows, voltage decreases. If resistance decreases, the amount of current that can flow increases.